Hi, good day everyone. This is example number 1. We are going to graph the function f of x is equal to -2 times x plus 3 squared plus 4. We are going to label the vertex and we are going to label the axis of symmetry. Okay, those are two very important vocabulary words. So why don't we just go ahead and get started? Something that I want to start with is vertex form. That should not be a surprise because we've done vertex form for quite a while now. Vertex form is how we know the transformations of a function. Okay, in this case, the quadratic function. Vertex form is given by y equals a times x minus h squared plus k, where the vertex is h comma k. All right, now let's go with what we are given. We are given f of x equals a -2 times x plus 3 squared plus 4. Okay, so based on what we have given, you all should be able to, from your prior knowledge about transformations of quadratic functions, you should be able to say, what is a doing to the graph? 3 as well as 4. So here is how we're going to start this. Okay, we are going to start this by first identifying what is A, what is H, and what is K, given what we have here. Okay, so we need to know what does A equal, what does H equal, and what does K equal, because that's the important information that we need to know about this graph in order to start thinking through what this graph going to look like. Okay, so I'm going to pause it while you write down what should A, H, and K be. All right, and just to let you know, A is a -2, H is a -3, and K is equal to 4. So now we're going to take what we know about vertex form. Your vertex in this case is whatever H is, comma K. H can be treated like your X value, K is your Y value then. So we know for a fact that we have a vertex. We're going to write down what it is because we have to label it. So we have a vertex here at -3, +4. So that's going to be the first thing I'm going to plot. 3 to the left, 1, 2, 3, 4 up. My vertex is at a -3 and a +4. Now, the reason why I wrote that above where that point is because I know this graph is going to open downward because there's a negative in the front. That's why we spend so much time on transformation, so you can predict what's going to happen. Now what I need to do is figure out what is happening on this graph. So what we're going to have to do here, I'm going to leave a little space for our axis of symmetry because I want to be able to write that down as well, because that's going to be an equation. Your axis of symmetry is a line. And here we go. Let's see. I'm going to make a table here. My table is going to consist of, why did I put X? Oh my gosh. I did not mean to put that. I was about to write X is or X equal. I'll tell you why in just a moment. But X, and we're going to have our output for f of x, our original equation. I want to see what's going to happen at a -4 as well as a -5. Or you could have picked a -2 and a -1. You should still get the same results. Okay, so the next thing that I'm going to do, now that I've identified what A, H, and K is, I want to now evaluate the function when x is a -4, and then you're going to do the one when x is a -5. So here we go. I am going to evaluate the function, and what I'm going to evaluate is when x is -4. So I'm going to substitute in f of a -4 into the original equation. I'm going to have -2 times -4 plus 3 squared plus 4. Okay, now what I'm going to do, I've substituted it in. So I'll write my steps. That was substitution. Substitute. And now what I'm going to do is simplify what is here inside the parentheses. So I'm going to do parentheses next, and everything else will get brought down for the ride. So this is still going to equal a -2 times a -4 plus 3. That's like me borrowing $4 and only paying you back 3. I still owe you $1. Okay, plus 4. The next step that we want to do is deal with our exponent here, this 2. So we got parentheses, exponent, and so far we are following the order of operations pretty good here. Okay, that's a -1 times a -1. Negative times a negative is positive. And to that we will add 4. Okay, step by step, pound for pound, this is what we're doing. Okay, I'm just joking. Next, we are going to multiply. We are going to multiply a -2 times a +1 and get -2. And we still add in the 4. Okay, and the last thing that we're doing in this case is to add. Okay, we are adding a -2 plus 4. So that's going to be a +2. All right, so we have a point when x is a -4 and y is 2. So I'm going to get my pen and plot out -4, 1, 2, 3, 4, and up to 2. Boom, I got a point right there. Okay, now I evaluated the -4. Why don't you evaluate the -5? So pause me. Don't cheat. Don't skip ahead. Won't you do it yourself? Practice makes better. Did you get this first line? Did you get the second line? Did you get the third line? Did you get a -4? Okay. If you got a -4, raise your right hand, pat yourself on the back. Good job. Okay. So I am going to plot a -5, -4. So that's going to be 5 to the left and 4 down. Here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4. I didn't label that point. -4, 2 was that one, and -5, -4 is my new point. Okay, now some things I just need to focus on. Focused in because I need you to see something, okay? This is the vertex, okay? I'm going to put vertex in red, okay? That's my vertex of my graph. My vertex in this case happens to be my maximum point, okay? The maximum value in this case, y, is a +4. That's how high up this graph is going, okay? Vertex, maximum point, the maximum value is y equals 4, okay? Now, here is why I said I will come back to the axis of symmetry, okay? Knowing that the vertex is at -3, 4, your axis of symmetry is going to be when, oh my gravy, I lost my ruler. Oh, there it is. Ha. All right. The axis of symmetry happens when x is equal to a -3. So I just smeared my word. It was on the tape. Oh my gosh. Okay. We draw axis of symmetry. It could be a solid line, but for the most part, you will see it noted with a dotted line. That dotted line represents the axis of symmetry. And if you missed it on the first video that I made, I told you how you can recognize the axis of symmetry. Notice the word axis in axis of symmetry says x is. Is in a math class is equal. So whenever you are asked to write the axis of symmetry, the axis of symmetry is denoted with x is. What is x at the vertex? If you wrote it down, or if you look right here, it is a -3. Okay, so that line, that vertical line here that intersects the x-axis here, That is the axis of symmetry. Okay, now why is that important? Why did we zoom all the way in on that? Well, if what you have here in red is your axis of symmetry, it is cutting the graph in half. So what that means is that if you have a point that is 1 away from the axis of symmetry at -4, 2, then on the other side of the graph at a -2, 2, you're going to have another point based on that axis of symmetry. Okay, here we have a point at -5, -4. So that's 2 away from the axis of symmetry. So if I go 2 away here, we're going to have a point at -1, -4. Okay, so this graph, oh geez, is going to look like, and I'm stressing like because y'all know I can't draw. This graph is going to look something like this here. Okay, you have plenty of graphing things that you can use to get a more accurate graph, but according to the rules of transformations, you should have known what was going to happen. The A being negative, we knew it opened downward. We know that the graph shifted up 4. We know that the graph moved to the left 3. And then that 2 just meant that the graph grew at a rate 2 times as fast. So that graph got narrower. So that's a vertical stretch by 2. Okay, now that is the end of example 1A. I'm going to do example 1B on another video. See you next time. Bye-bye.